Hi and Assalamualaikum. My name is Nur Syafiqah binti Kamarul Bashah and my student ID is 2021602862 and I'm supervised by Madam Siti Hafawati binti Jamaluddin. I would like to present on my research proposal, which is optimization of vehicle routing problem for sustainable municipal solid waste using artificial bee colony algorithm. Contents in my presentation includes Chapter 1 Introduction, Chapter 2 Literature Review, and Chapter 3 Methodology. Let's start with research background. But before that, I would like to explain on VRP, Vehicle Routing Problem, and CVRP, Capacitated Vehicle Routing Problem. Vehicle routing problem (VRP) is a common problem in the logistic and delivery industry, resulting in inefficient outcomes such as inaccurate delivery routes, resource and time waste, and customer dissatisfaction. Next is the capacitated vehicle routing problem (CVRP). CVRP is a problem regarding the ability of delivery trucks to transport packages. The capacity of each delivery truck or vehicle is utilized by CVRP to determine the optimal routes, ensuring timely reach to every customer or point. Next is waste generation. It is increasing due to the population growth, economic development, and industrial expansion. There are different types of waste, such as municipal solid waste, industrial waste, agriculture and animal waste, medical waste, construction waste. The impact of these wastes are dangers to human health due to lack of proper waste management. It also gives negative impact on the ecosystem well-being. For the problem statement, municipal solid waste including waste from residential, commercial and institutional sources such as food waste, packaging and paper waste. It is crucial for environmental and public health. Poor management will reduce quality life, especially in poor housing areas. It may contaminate landfills and oceans with microplastic and other persistent materials. It may also threaten human health through exposure to pollutants. Next is the research objectives. The study's main goal is to optimize the vehicle routing problem for solid waste collection using the artificial bee colony ABC algorithm by finding the shortest distance routes for waste collection vehicles. And the specific objectives are to obtain optimal routes with minimum total distance and to calculate the total carbon emission emitted by the vehicle. Significance of the study: the first one, proper waste collection can benefit society as well by preventing the spread of diseases and decreasing odors associated with improper waste handling. Second, a well-organized waste collection system will reduce the operational cost and can generate more profit to the government or company which handle to waste collection. Third, this study may highlight the importance of proper waste management to the public health. For the scope of the study, data, collection point locations and waste loads will adopt from Kiao et al. 2020. There are 6 disposal facilities and 47 collection points. The findings is expected to obtain the optimal routes with minimum economic costs in terms of shortest distance. Besides, the cost of carbon emission emitted by the vehicle can be obtained since the distance of the routes and waste load may affect the emission. Waste collection is a highly visible municipal service with significant operational challenges and costs, meaning that there will be significant operational and environmental expenses, by Ki et al. 2023. A research done in 2021. From a health perspective, a study was conducted in Accra on household waste management challenges. Roughly, half of the respondents used illegal waste disposal methods, while the other half used public bins. Most respondents admitted that poor waste management could impact the health of household members. A study was done in 2021. Improper waste collection may impact the environment and public health. In terms of environment, it causes land, water, and air pollution, endangering the health of both people and animals. Municipal solid waste collection (MSW) is an important aspect of solid waste management. The term MSW refers to the most complex types of solid waste, which exclude hazardous, industrial, and construction waste, and includes waste from Institutional, Commercial and Residential Sources by Kiao et al. 2020. As waste management is usually an urban service, waste collection rates are much higher in urban areas than in rural ones by Triasi et al. 2023. Such a system is intended to allocate garbage trucks to separate municipal solid waste, as well as to determine the routes they will take and the daily quantities of separated municipal solid waste that will be required to be delivered to each specialized sorting facility or landfill to reduce the overall cost of the service, even though the service desired quality level is assured. By Corsil et al. 2020. Artificial bee colony ABC was developed by Karaboga in 2005 to optimize numerical problems. Based on Puribun et al. 2019, the artificial bee colony ABC is used to find the best solution to the true optimal solution. ABC behavior has historically tried to mimic how bees gather food. An artificial bee colony ABC-based hybrid approach was developed to handle a waste collection problem, considering a midway disposal pattern in which the hybrid ABC algorithm is proposed to generate a better optimum seeking performance. It was tested on dataset where the result shows that the proposed approach is superior to the other four approaches, namely genetic algorithm, a particle swarm optimization algorithm, an enhanced ABC algorithm, and a hybrid particle swarm optimization algorithm. In this study, the data on waste collection is adopted from Kiao et al. 2020. The numbers of disposal facilities and collection points are 6 and 47 respectively. There are a total of 16 vehicles each with a maximum weight of 80 tons. In the dataset, the scheduling of this dataset is planned for 5 days a week. The information about position and waste loads of collection points on Monday was only provided by Kiao et al. 2020 and is presented in Table 3.1. A graph with a collection of nodes and associative edges is used to model VRPs. The consumers and depots are represented by the set of nodes, and the routes connecting them are represented by the edge. Several vehicles depart from the depots, visit the collecting point, and return to the depots. The main objective is to find the shortest distance routes for waste collection vehicles. Therefore, equation 3.1 is used for calculating optimal routes with minimum economic cost in terms of shortest distance, where alpha is the correlative coefficient illustrating the proportion between economic cost and distance travel. The municipal solid waste model becomes more practical by taking into account more constraints. So, these are the constraints. The externalization of environmental influence is measured in terms of carbon dioxide emissions. We then attempt to identify the best route with the lowest carbon dioxide emissions while considering the balance between carbon dioxide emissions emitted by a vehicle traveling from point I to point J and the traveling cost on each. Fuel consumption rate is determined by the distance traveled and the load of vehicles. The emission of carbon dioxide is caused by the consumption of certain type of fuel for vehicles. The emission rate of carbon dioxide CER is fixed provided that the type of fuel is known. Next, the fuel consumption rate FCR as in equation 3.11 is determined by the distance traveled and the load of vehicles. To calculate FCR, a linear expression between fuel consumption and weight of vehicles is adapted and integrated into the model. The empty load and fuel consumption rate of vehicles are denoted as P node and P star respectively. As a vehicle K travels from collecting point I to collecting point J, the distance travelled and the vehicle load of vehicle K are represented as Dij and Qijk respectively. Then the carbon dioxide emissions for vehicle K represented as equation 3.12. The colony of artificial bees contains 3 groups in ABC. Employed bees associated with specific food sources exploit and improve them. Onlooker bees observe, exploit bees, dancers, and choose promising food sources. Scout bees randomly search for new food sources. Based on the flowchart in figure 3.1, there are 4 phases in artificial bee colony algorithm. The phases are the initialization phase, employed bee phase, onlooker bee phase, and scout bee phase. And lastly, this is the pseudocode of ABC algorithm. That's all from me. Thank you.